what's your goal? What's your focus? Like, what is your strategic goal? Is it to have this system that you've built yourself from the ground up, that you've got all the servers and you can give yourself a pat on the back and I manage this myself? If your goal is to get more done quicker, serverless certainly enables you to do that. The trade-offs are there is that as your scale grows, it scales with the volume. You use a million more requests, you're going to get billed for a million more requests, but you didn't have to have any sort of auto-scaling built. You don't have to add new servers. You don't have to have alerts or monitors set up to do that. It just works. It's the Ron Popeil, just set it and forget it.
Welcome to Tech Council, your go-to podcast for mastering the art of building in the enterprise world. Join hosts Duncan and Jason Ehmke as they unpack the strategies, tools, and insights you need to drive innovation at scale. Brought to you by DevGrid, we're here to empower developers, tech leaders, and enterprise builders. Hit subscribe, and let's dive into today's episode. Ready for episode 2 of Tech Council, Building in the Enterprise. I'm Duncan here with Jason Ehmke again to talk about one of the more, in our opinion, interesting debates in the kind of software development world. These days is kind of serverless versus Kubernetes or containers. So I'm kind of pumped to talk about this.
It gets a little spicy. I've had a few of these conversations with many app teams, and there's some strong opinions here. I wasn't prepared for how strong people feel about each of these systems and how much pushback on using serverless. So let's get into it.
Yeah, awesome. Yeah, so we were thinking about how to start the conversation. I'm a convert to the serverless sort of philosophy, right? Like I remember back when I left. When I was at Bank of America, I was pushing hard to try to get us to containerize. Like we had a very heavy VM shop, big giant JVMs and all that jazz. And then when I got to Passport, where you and I met, I was like, I thought containers were the way to go. And the head of the cloud team, pulled me aside and was like, "No, serverless is so much better. Let me explain this to you." And he was a super smart guy, knew a lot more about it than I did. And what became obvious to me over time is how much better it is to operationalize serverless at scale and stuff. So, but what about you? Like, what was your kind of origin story around serverless? How did you start?
Well, it's about the same. I did mess around with Lambdas a little bit before I came over to Passport. We were trying. No shock. I got a lot of pushback, and a lot of the guys were very much pro Kubernetes or wanting to push on pods, and it's better for all these reasons. And it was a small team, and they really didn't take into consideration the management of these pods and how much time we had to spend on managing the pods, restarting the pods, and orchestrating the pods. We had a person that was dedicated just to infrastructure on a team of 4 people. We had a 5th for managing infrastructure and DevOps. And, the big argument was, well, what about the cost for our scale? It's like, well, it's actually A, cheaper, and B, you don't have to have a person dedicated to it. So, a lot of those factors weren't even considered. And then coming over to Passport we really did the real math of things. It was pretty eye-opening on how much better it was for what we're using it for. Now, clearly it's not better for everything, but for what we were using it for, was the clear winner. It was refreshing with how easy it was to maintain and build with just the right support on that.
Yeah, for sure. I mean, I think from my perspective, when people, we get into this debate all the time with different customers and clients and things like that to try to help them through their cloud strategy and their cloud journey. I think. There's pros and cons on both sides, right? Like, and the beauty of Lambda, kind of that's the main serverless thing that we think about when we think about serverless, but obviously it includes things like, queues and event systems and stuff like that. The catchphrase that I like to use is I want to be billed by the millisecond, not by the hour. Mm-hmm. And fundamentally that's, that tells you what the service you're using and kind of how it matters. The fundamental thing that I think you sort of hit on of why serverless is so powerful is the operational simplicity, right? And like to your point, everybody focuses on the technical aspects of, hey, I could run a blade in a data center, for $1,000, I can stand it up, rent it for $50 of electricity and networking a month. And boom, it's way cheaper than your cloud service, and even more so than the incremental cost of like a Lambda. The difference is, I think, is the complexity of, to your point, like back to Kubernetes, the complexity of maintaining that well and scaling and having all that done. You really need deep expertise. I mean, we've seen it. Won't name names. We've seen places that have huge Kubernetes deployments, or something that wraps Kubernetes, that is a disaster, right? Like
it's unmitigated disaster.
Entire companies to the ground because they can't keep it up, right? Like the expertise you need, you got to have really smart people and a lot of them, or at least a handful of them. And that, to your point, like that, and then everybody else needs to understand the complexity of the Kubernetes ecosystem as well. So it's a bit of a challenge because, and you made the right point about cost. It's people are far and away the larger cost in technology, right? Like I've run these my bosses have had the hundreds of millions of dollars a year budget, and I've helped plan them, right? Like the infrastructure stuff doesn't come close to touching the amount of spend on people.
Yeah,
right?
there's trade-offs, right? Like the saying that we always say, there's no solutions, only trade-offs. But yeah, the reality is here. What's your goal? What's your focus? Like, what is your strategic goal? Is it to have this, this system that you've built yourself from the ground up, that you've got all the servers, and you can give yourself a pat on the back and say, I manage this myself. Yeah, I have to have a whole team of developers that are supporting it, but forget about that for a second. We've got this whole thing that's look what this is. But if your goal is to get more done quicker, well, serverless certainly enables you to do that. The trade-offs are there is that as your scale grows, it scales with the volume. You use 1 million more requests, you're going to get billed for 1 million more requests, which, okay, fine, but you didn't have to have any sort of auto scaling built in. You don't have to add new servers. You don't have to have alerts or monitors set up to do that. It just works. It's the Ron Popeil, just set it and forget it.
Yeah, I mean, there is, it's a complicated calculation. There are some curves where let's talk about it like directly, right? Like some of the pros and cons. Like if you have very latency sensitive applications, serverless isn't great, right? Like it's not the best thing. If you're building a high frequency trading operation, for example, Lambda is not going to be the right choice for you because every millisecond or every microsecond matters. And there is an overhead to these systems. Now, that being said, that overhead is not necessarily that large, right? Like we're talking, if you optimize it well, maybe it's 10, 20 milliseconds per call max, right? Like if you do it well. I mean, cold starts, they have the tools now to basically, push that away. But that's latency sensitive things, long running tasks, right?
If you got like a multiple gigabytes of files, right? Lambdas, you have to do some tricky things to make that work. It does take longer to make that work when you're parsing out giant files. It's not as easy. You could just load the file in a container and rip it apart and be done. Fine. It might be a case for it.
No, yeah, with Lambda, you have to if you're using Lambda, you're like, okay, well, you're using API gateway to front it most likely, although you don't have to do it that way these days. And then so it's like, well, that also has its own limits, right? Because AWS API gateway is limited on purpose. And so it's like, to your point, you can't just ship a giant file over. You have to, create an S3 link and then push it to there and then read it from there and all this other thing, which is not a bad architecture, but it's a trade-off, right?
And then if you're working with the partner team where they might not be used to having to split up and chunk a file, where they're having to build things themselves to integrate with your system. Well, again, what is your mission? Is your mission to get the job done right now, or is your mission to, I guess, build this thing that's orchestrated with, pristine care and you've got to take this multiple gig file and split it up into 4 or 5 chunks because your system isn't designed for it. Well, now you're putting your architecture and pushing that on the other team. So in that case, it's likely better for a containerized system with significantly large files like that. And we had to do that. We had to rip some files apart like that, and we had to. There's a lot of collaboration that was needed to get a team to see our vision of serverless, and it actually caused some friction because it delayed by having to have them split the file like that. Now, at the end of the day, they saw it and we were able to justify why and why it's better this way, but it just takes some coordination, collaboration to make sure that you're not imposing your architecture on the other teams.
Totally. Yeah, no, it's a thing, right? Like in trying to make all that work can be, part of the negotiation that's important. And, as we know, not all decisions that get made in these environments make sense from a technical standpoint. There's political negotiations about who's going to create the work and all those different things. But again, like what I come back to is I want to optimize. If you're going to optimize for operational simplicity and stability and scale, right? Like that's sort of our bias, right? So like we built DevGrid ground up serverless as possible, right? We obviously have a few things that
we have
are
containers.
But yeah, we have some, but the vast majority of the app is serverless, right? So that comfort that gives us from an operational standpoint is huge, right? Like we don't, to your point, like we're small startup, right? Like we don't have to have an infrastructure team. We don't have to have some DevOps, Kubernetes master in there playing around with stuff. Everybody's shipping code. Nobody, like infrastructure is just something you put in a CloudFormation file or a serverless file, right? Like, and it's not something we have to worry about because we just abstracted that problem away. And that's why I love the cloud stuff, right? Because we don't have to be experts in infrastructure management because they are. And we just, obviously you can't be completely ignorant. You have to do things right and all that type of stuff. With that caveat, like for the most part, we're delegating that stuff to them. So therefore it makes it easier for us to just focus on our differentiated value.
Yeah. And, there are certain, not even just use cases like volume or scale or file size. There's even dependency sizes. Looking at the machine learning dependencies, they just don't work in a deployable to a Lambda. They're just, they're too big.
Yeah. The memory needs and all that type of stuff. Yeah, I don't know. I'm sure someone's figured out how to load Llama, one of the Llama models into Lambda just cause, but yeah, no. I mean, to your point, it's not good at everything. Although, the other thing is like serverless is more than Lambda, right? Like some of its philosophy and approach, right? Like we use a lot of AWS batch, right? So we run our stuff in containers for that same reason, primarily for batch. It's the reason we do it. Some of it's resource size, but it's also for runtime links, right? Like we might, the first time we pull data from an integration, for example, some of our customers are big customers. It's a lot of data. And so it might take up to an hour to pull, and also they rate limit us so we don't take their systems down, right? So it might take an hour to fully download from their APIs or from the vendor APIs, everything that we need. Well, obviously you can't run that in a Lambda. And if you want to run into a Lambda, you have to do some sort of state hopping and it's like, it can take
to orchestrate that and build it. If you're scrappy and just trying to get the job done, having a multi-part batch function using serverless and Lambdas is just, it's the wrong approach. It's going to take you.
We started.
Yeah, we tried.
We tried that. It was a nightmare.
But it's a trade-off. Like, what are you trying to get done? You need to get the job done right now. Okay, sometimes if it's not a mission critical workflow, you can throw it into a container and just come back to it. Make it work and make it better. That's some of the thing too.
Well, that's one of the other things, like little side tip for anybody that is out there building, what you said, non-mission critical, asynchronous batch processes. AWS batch with a Fargate spot instance is basically free. Like it's unbelievable. Like I remember the first time we I pinged you. You remember that?
Are you sure?
Because I was like, there's no way our price. This is what we just spent on this last month. It was literally like
a few bucks.
It was like nothing, and it was we must have run so much through that. So it was.
We're running millions of records and all those commits that we're processing on that. It was pennies in the dollar what we would have thought of.
Yeah. So that's, if anybody's out there trying to think about that stuff and keep the costs down.
Spot instances are a hidden gem. And if it can be spun up at any time like that, spot instances are a great approach.
Yeah. And we actually had one, the first time it finally happened, we had a failure because they reclaimed, remember this happened like
That's
3
right.
years ago.
Yes, they yanked it
reclaimed
back.
Like, wait a minute, my process was running, they reclaimed it, but it was like, who cares? It just ran again. Like because the thing manages the queue and you just have a retry and it just runs again. And so it's like, oh, okay, cool.
Yeah,
So,
and those who don't
obviously,
know what those are, the spot instances are the servers that are sitting idle that AWS is paying for. So they loan them out for cheaper that anybody can just grab a spot instance. But if at any time AWS needs to pull that back for an actual paying customer at the full list rate, they yank it back and your job is done immediately. So we use those because a lot of our background processing can just be restarted at any time.
Yeah, exactly. So it's a cool little thing about serverless. But the point of it was with serverless is it's not just Lambda, right? Like, I mean, we are total SQS addicts, right? Like we use that like crazy. And obviously Lambda lends itself to, the power of that type of stuff. I mean, I know you guys, you want to talk about the stuff you did, without at one of those banks, we'll say, around how you guys broke out your fan out processes and stuff like that.
Yeah, that was a fun project. It was, how do we keep everything up without, having to re-architect and rebuild the entire thing. So we re-architected to a serverless, and it was are you sure? And I still remember that at the time that none of the tooling was set up for it. But the long story short, we moved from containers to serverless, and we went from hundreds of incidents to next to zero for this. And the whole point is that if you can keep your servers up without breaking the bank, no pun intended there, but you can vastly reduce your incidents. But for us, what we did is we built an SQS fan out where you would take a single event, and we would put a list of a list into a queue, and that would fan out to multiple consumer lambdas, which would then in turn have 5 packages of 5 lists, and we keep fanning that out. So now we're running millions of these events in parallel, effectively, because of how fast you can fan out from one to many. And now with Dynamo,
and this was part of your cache rebuild process, yes, right? So you're taking in a giant data set from a downstream system because you're creating an ODS layer, right? Like that was the whole point of this, right?
Yes.
So you're creating that ODS layer, and you want to keep that data up to date as much as possible. So you're getting regular dumps of giant, whatever they are.
Well, I think we took 11 million records, and we were able to process that within a matter of an hour. And insert those into a database with no collisions, no Mr. Drop records. It was with the power of Dynamo, being that it is serverless, that it can pretty much handle whatever you put at it. It made it easy, And
you could have gone faster. That was just that was a good number for you because it kind of kept you in a nice rolling basis without overloading anything, right?
Yeah. Right. Yeah, because you can be rate limited with Dynamo, and we found that out. So we did have some of our own internal throttling to make sure we didn't hit those Dynamo throttles. It can handle things, but if you put too much at it at once, they will throttle you.
So that's a good call. That's a good call out of kind of like one of the trade-offs with serverless. Again, Amazon in particular, they put a lot of circuit breakers in there, basically, right? So because you can get recursive and the serverless stuff could just go boom if you're not careful, right? And so, like, talk about like what are some of the things that you do or have your teams do to stay ahead of those? Like, what are the things they need to think about where the places that the controls kind of clamp in?
Yeah, it all comes down to the first part is planning. What are you trying to do? Like, what is the end goal? You want this file processed into this database. Okay, great. Now, how much time do you have? Do you want to be babysitting this for 2 days? Okay, well, no. You want to be quick. And what are your limits? What are your rate limits to Dynamo? Well, sometimes the answer is I don't know. So we start looking at what are the rate limits? How many concurrent requests can we process here? What is our scaling? What's the what options do we have available for us? And so the team did some work on just analyzing what can we do to put as much in a single message as we can, and what's your message limit. So now with SQS natively, a lot of developers will think, well, I'm going to put a single message into this event and send a single message. Well, they got creative and said, well, actually, I could put up to 25 messages into a single event. And now my subscriber can say, give me 5 of those. So they were getting these multiple lists of these envelopes of events, and getting a little bit creative of, okay, well, I can get more throughput by maximizing the input to the output of the Lambda by taking multiple events at the same time and processing. So I guess what I'm trying to say is that, forcing the team to think a little bit out of the box and challenging some of the assumptions of one event to one Lambda. No, you can have many events to one Lambda. Well, actually, you can have many events in a single Lambda and maximize that processing so that you've already got the connection over to Dynamo. Reuse that connection. You've already had that Lambda spun up. It's already processing. So running another iteration on that same Lambda is you're maximizing your resources. But then forcing that, do you want to be babysitting this thing for 30 hours? And they actually did that at first until they realized, I don't want to do this anymore. And so they re-architected it to maximize the parallel processing, but also look at the AWS limits themselves. Like what can this do, and what's a soft limit, what's a hard limit, and how can I just squeeze out a little bit more processing power for each of the Lambdas? But then
so you said a few things
itself too. Like the one thing that's lost a little bit is well, I don't need that much memory, but actually the CPU scales with the memory itself, so you can squeak out even more power by increasing your Lambda size and get that job done quicker, because you're built on like you said earlier, you're built by the millisecond. But if you have a Lambda that's you maybe have to pay 10 cents more per minute, but it's reducing your speed by 2/3, you're actually cheaper by using a bigger Lambda because you're getting the job done faster. So, just trying and testing those things and looking.
There's a lot of levers.
Right?
Like that's the thing. So I heard a bunch there. So just to kind of recap, like some of one of the things you're saying, right? So one of the levers is how many concurrent Lambdas do you want to run, right? So you've got a feed, and then you can, there literally is an ability to just say how many you want to let go concurrently.
Yes, it's a setting, just how many do you want.
Yeah, that's a lever. And then you're saying, so that's a horizontal scale out lever. And then you have this kind of, there's 2 different types of vertical scale out levers. One is, what I'm hearing you say is you, instead of one event to each scaled out Lambda, you might send 10 or 20 or 100, depending on how you,
right. JSON stringify 5 events at once instead of 1.
Exactly. Right. So you can use SQS has the natural, you could send a single record, and then it lets you choose how many records you want to send, but you can also in your record embed a lot of records, right? And that's what you're going to say. So there's different layers, and this is one of the powers. Like even when we've built integrations and things like we've done, one of the things we really like about using these queues in Lambda is it lets you inject essentially speed controls each place along the way. Because some of these big processes like Lambda, you can DDoS yourself pretty quickly, and I assure you that's never happened. I've never done it. This week. So it's definitely doable. You could DDoS yourself. And so like one of the things we've been really good about is when we can, we're putting those queues in place, and then we can ratchet down. Like, hey, let the queue build up. It'll, like you might have 1 million records to process. We only let it do 10,000 a minute or something, whatever the number is, just to make sure we don't put too much load on the downstream systems. Right. And so it's a load normalization thing when you can. Again, it depends on your latency needs, and obviously asynchronous. You want your business processes to be asynchronous as much as possible, but also customers want to see data in the like in our platform, they don't want to be a 24-hour refresh cycle. We want a faster refresh cycle. So how do you do things like that? And then the other vertical scaling that you were mentioning is the actual traditional vertical scaling in terms of the resource size, right? So if you crank up you know, and what you said is a good thing that most people don't realize is that the memory size of your Lambda directly correlates to the CPU. You don't get to choose between those independently, right? So,
Right.
so that then the number that is kind of shown as you look in the console or in your infrastructure's code is the memory size, but that corresponds to a virtual CPU, and then sometimes that can really help. There's a lever there to, if I get this done faster, but like the sports car might, the analogy might be the sports car has half the mileage, but it only doesn't have to go as far, right?
Right.
And so it's you end up using less gas, and so it's the same kind of concept. So that's pretty cool.
Yeah, and a lot of people didn't
What
think
a-
about that. You just don't see it because you build by time, by memory, by time. But the hidden factor is that CPU will squeak your time even lower, even though you don't think you need the memory. It's worth testing.
So I want to talk a little bit more about Kubernetes and containers in general and things like that. But before we do, there is some kind of new news. You and I haven't even talked about this. I'm not sure if you're even aware, but in the last few days, Amazon has announced that they are going to now start to bill for initialization time, init time as it's called, on their provided runtimes. They've always billed for that on your custom runtimes, right? You build your own Docker container and bring that along. They've always kind of billed you for that. We're like, hey, if you're going to do your custom thing, it might take forever. We're going to bill you for that. But now they're going to bill it for everybody's stuff. So,
Which makes sense.
Which is
you're using it.
So basically paying for cold starts, right? Which is kind of, the first reaction to that is like, what the hell, guys? Like, I don't want the cold start. Why are you billing me for a cold start? But actually, it brings in the economics of, to your point, bundle size, startup time, like all those things it basically kind of kills the idea of using a Java Lambda because that part just got way more expensive. Also makes it more important to manage your cold starts. I don't know. I didn't give you much warning on that one, but what are your thoughts?
Well, it's something that the teams I've worked on have always really tried to optimize, not to the, micro optimization, but, cold starts, well, love them or hate them, mostly hate, but they're there for a reason, is that the server's got to boot up in the serverless world. Your serverless really isn't serverless. It's just somebody else's computer, but it still has to boot up or initialize. And the bigger your bundle size, the longer that's going to take, because it still has to load that bundle from the S3 bucket where it lives. And so it's always been a factor that we've looked at, just more for the customer experience of, well, my customer doesn't want to wait that extra 200 milliseconds for this API to respond. So, fundamentally it makes sense because, well, it's still technically yours at that time. It's just booting up, where they can't rent that
So
out
do
to
you
somebody
tree
else.
shake? Do you tree shake? Like, do you tree shake server side? Is that what we're doing? Like, seems like a silly thing to do.
It strips out your bundle size to the things that you're not using or that aren't necessary, or, splitting up your Lambda to smaller pieces. It actually does help in a measurable amount. Now, there's a lot of pros and cons. Like I said, there's no one size fits all solution to that. You might end up painting yourself into a corner by trying to optimize your bundle size, and now you're spending more time to get there for an extra 50 milliseconds. But a lot of it comes down to what dependencies you're using. And just to get into the weeds a little bit is the Express framework in Node. It's an API router. It's great. It's a great framework. I have no complaints. I still use it extensively, but some of the teams I worked on tested removing it. And there was a measurable difference for not much of a trade-off on not having it anymore. So they ripped it all out and went just raw from the AWS event to the Node app. And it was a measurable.
I can see that, right? Like, if you're in an enterprise environment where, like, you don't need all the middlewares, you don't need all that stuff, because all that stuff's being handled in other contexts. Yeah, no, totally. Express would be. I could see Express being heavy. That's although we still use it pretty heavy.
We do, but we don't need to optimize for that level of throughput, though. I mean, that's, again, it's an intentional choice that this gives us more safety, that gives us more security on a small team. The trade-off is in the favor of using it because it lets us deliver faster. Now, for a full team, they can absorb some of that by not using Express because they're optimizing for sometimes the throughput of the dashboard load, for example. That's something that you want to optimize, and it's going to spend some time on. For us, we need to get stuff done as quick as possible with the safety in mind and our customer data safety. So that's where Express is in the favor, because I can centralize all the middleware loading, all the security checks in one single place.
Yeah. No, that's absolutely right. So like back to, the whole serverless thing, like what are some other serverless features that we haven't talked about? Like not features, but like services. We'll stay with AWS, right? Like what are some other patterns or things that you think people should, are part of the consideration, part of the calculation? Because there is no, as we'll say, as you said, or we probably say it 5 times a week at least. It's like there are no solutions, only trade-offs, right?
Yeah. So the biggest argument that I get on using serverless, and it's not a bad argument, I think there is a time and place for things, is state management. Sometimes you do need to have your state managed in an app. And okay, well, if that's a need, well, then clearly, containers are something that you should, either stick with, evaluate, or see if you could abstract that away.
So
but
let's tear that apart. Why would you need to why would you need to have your state managed in an app versus, something like Redis or some sort of close, high speed, state manager?
I don't ever think it's really necessary. I think sometimes it's a pattern that was developed, and you don't want to have an extra service. You don't want to have a Redis server, Redis cluster. You can't afford it, or it's just too much overhead. So you throw it in memory.
It's to be monolithic,
right? You don't have a team to manage it. You don't have the resources for it. Well, okay, that's fine. I don't love the argument, but it's an argument that could be made, and that's typically the one that's thrown off the most. Is how do I manage my state? Well, my typical answer to that is, if you have state in an application, I would challenge your architecture to use something not that, because you reboot the server, the state is gone, or if you're holding on user sessions, everybody has to log in again, and so an API, for example, must be stateless. I mean, it must be. So if you need state, that's usually better in a session in a database.
Mm-hmm. Yeah. It's some sort of data store that's externalized. Yeah, because then you can't see. I mean, only the place where I would argue where I could see a strong argument against that would be if it's a COTS app, right? Commercial off-the-shelf software. And this is actually one of the best arguments for containers, I think. And you've got to give something to a team, to a customer to deploy into their data center or onto their machines. And the simpler you can make that, and the more self-contained you can make that, where I just turn my thing and I press run and it just does everything and it's all in there. And that, they don't, you're not asking them to stand up an extra database, or you're not asking them to stand up some kind of Redis or something like that to support it. Like I definitely see that argument, right? Like I think
you can use SQLite though too. SQLite, I think it gets a lot of use for development and local development, but it does work on scale for holding some session authentication. So SQLite is something that is it gets a rep for, well, I'll use it for local development. But you could actually use it for
it's just
something too.
You're just saying that's a good way to do local state, right? Like that's what you're saying, right?
Even
it's still local in-memory state.
Yeah.
Yeah. Cool. All right, so let's pivot a little bit. Well, actually, no. Let's complain about Amazon. Like, what do you think about them billing that stuff? Do you think that's is that reasonable?
Well, I don't love it. I think it's something that it's a limitation of their system, and then now they're billing for it. I think I don't think you can ever get away from it, but I can see the argument that why they do that, but personally, don't love it. I think it's
Well, yeah. I mean, nobody likes the prices getting raised, right?
Yeah.
Like that's exactly. But and it's funny, Amazon does a great job of never raising prices, really. But I guess they add new things, so maybe it's kind of the same thing. I mean, what's the argument? Like, if you're them, beyond just like raising revenue, right? Like, is there an argument to say we want to incentivize people to improve these things? Maybe you think that's part of it?
Likely, they could have a few reasons, right? Revenue is likely the number one candidate there. Like, they can't rent that to somebody else. That box is now used by use during your cold start, so they're going to try to get revenue off of it, because if you didn't have that cold start, they could rent that to somebody else. So revenue is likely the number one, but I think charging is the number one way to optimize, so that it's that they want you to be done with it as fast as possible, so they can go now charge somebody else for it too. So
Yeah.
it's
I
like a
forget who
turning
said
table
it.
of a restaurant.
I don't know if it was Bezos or Jassy or one of their guys at some marine event that we went to years ago. Or I heard somebody say something basically at a keynote, I think. And it was like, when you really think about it, we're selling electricity. Like at its base core, like, kind of first principles, we're selling electricity, and we want to make sure that we're billing for the electricity we're consuming as much as possible. So it was a kind of an interesting way to think about it. So, all right, so let's take the other side a little bit, right? Like, let's take the container side, and I'll kind of lay out, some of the high level arguments we've heard, and then let you kind of go to town on them. But, one that I know you and I have heard a bunch of times is they want to avoid vendor lock-in, right? Like nobody wants vendor lock-in.
Which is
so
fair.
They think,
that's a fair argument.
yeah. And theoretically portability as well, right? So like you can run the same service. I mean, this was a debate that a certain CIO and I had an ongoing debate, very friendly, but also very contentious, around whether or not that was actually going to work, right? Like of having a bunch of containerized apps in a proprietary data center, and then also running those same apps in, hyperscaler in AWS, and whether or not that was a good strategy for portability and flexibility. And kind of the idea was the main data center would sort of be the base, and then you use Amazon for like burst capacity and things like that. And again, it kind of violates some of the principles that we talked about, like how do we make it operationally simple and safe? Like that's kind of really complicated, but there is that, right? Like if you want to be able to go, if you're, the trend lines we've been on with cloud are totally wild, and Moore's law, all those things. Like it's Amazon, and because Amazon's at the forefront of it, and Amazon having their DNA, the corporate DNA, be tied to the logistics business, has made them so efficient and so cost sensitive, and then passing that cost on to the user, to the customer, or passing that savings and efficiency on, that they just continue to drive the pricing, the cost of these things down over time. And now you've got their own chips and all this different stuff, right? So if, but you look at like Microsoft and Google, that is not who they are, right? So the thing is as they get more market share, if Amazon, Bezos is now not super involved, Jassy's the guy, but he's also running the whole company. Like maybe that sort of founder mode starts to go away a little bit. And then if it starts to change, then, locking could get scary. Like we've seen what's happened with some of these vendors. So we don't want to get any letters from anybody, so we'll leave them out. But some particular software companies in the infrastructure business got bought out, right? And then all of a sudden turn around, they're tripling, quadrupling the costs of the software because they know it's hard for people to get off it, right? And they're like, oh, we're going to burn the bridge with the company. That's fine, but it'll take them 5 years to get off of the software, and we'll just print money in the meantime, right? So that's so you see that happening in the infrastructure space, even though it's never happened. Nothing like that's ever happened in cloud. Like there is an argument to be made there.
Yeah, I think it's a fair argument. I do. I think it's a risk mitigation technique. What happens if the price goes up at Amazon or in the serverless or whatever you're doing there, and it's okay. Well, it depends on these individuals that they also have a stake in things, and we talked about this last time about caring about what your partner teams care about, just like it's yours. And so if they have a fair argument to say, well, what if? Like, okay, first off, it's not very likely, but say hypothetically it does. These apps aren't built with a vendor tie-in directly. You can port a Lambda app over to a container fairly easily. And we've done that. I did that recently. I had a Lambda. It was a Python Lambda, and started putting some machine learning into it. And okay, well, this is not the right approach to use serverless anymore. So I converted it over to a container. And for somebody who's never had to do that directly, that kind of a conversion, it was not as painful as you might think. It took me a few days with the new AI tools and whatnot. Just for a solo dev doing that, it's not going to be a challenge, and you aren't as locked in as you might believe. Now the interfaces are different. Data coming in is structured differently, but you can port those over if you build
That's
them
pretty
right.
easy to.
If you build them right,
Yeah,
so
yeah.
that's the thing is that not thinking of the future and building with vendor tie-in. That's your mistake in the first place.
Yeah. No, that's fair. All right. So what are some of the other pros? So we talked about latency. We talked about like the vendor tie-in piece. Um, what are some of the other benefits? Actually, those are the ones that I can sort of think of. I mean, the portability is nice, right? Like serverless can be a bit of a drag on your local machine, right? Like you got to get, I mean, there's some tools that
Testing is
help, local
different.
stack, that
Yeah,
type of stuff.
if you want to, like that's I think one of the flaws that I see developers trying to develop. Well, I want to run this locally, and I think that's a flawed, I guess, desire. Um, you shouldn't.
Interesting. Say more.
Well, the one of the DevOps guy that worked with at a previous company, he had a pretty strong argument against this, and I was asking about how do I test this locally. He said, "You don't test a Lambda locally. You test your code locally." And it took me some reps to get through that. And his argument was, well, you can mock the event going into your code. That's going to be the same as the runtime. So why wouldn't you do that? Okay, that's a fair statement. It's a fair ask. And so if you were unit testing, reduce the need to even test your quote unquote Lambda locally. And a lot of developers will want, I just want to know, I want to have this in local stack. Why? What is your testing practice like to mock as much as you can? And I don't, for all of our stuff, I don't test anything. I test it locally, but I don't have to have a running instance of it to test. I mock the interfaces of it, pass in the data just like AWS would. When it's deployed, maybe there's a couple tweaks that I have to make, but it just works.
So that's interesting. So and there's really kind of like an application architecture thing to that too, right? Because it's not an application architecture, but like development philosophy, right? Like because I mean you and I both know this from the way we've written code over the years, right? Like I'm more of a change something and push it and play with it, right? And what you're really advocating for is more, no, build yourself a testing harness and a testing framework and do it that way, and then debug in the environment instead of trying to create a local environment that matches the environment. Because again, you can't. And it's hard, right? Like if you think about, and this is where the vendor lock. The only place I would push back on what you're saying on the vendor lock-in is like if you're really going all in on like cloud native and serverless, it's not just your app, right? Your whole architecture is sort of dependent upon a lot of the services usually.
Yeah, there's a point of no return there. There is.
Yeah, or it's like, you're all, you're usually pretty event driven and all. Again, it's stuff that you can't convert those things. And if you build it properly with the right, the right kind of structure, then that becomes a lot easier. But it is, those types of things that's a cool point. I actually never heard you say it that way. Like, and shout out to Kevin, because that's a good idea. But the to think about it is like, no, test your code, not the environment. That's you guys are almost going to talk me into writing tests. I'm not there yet.
All these years, that's a big takeaway that I had there. It made a lot of sense, and everybody I've talked to since then is like, I want to clone the environment locally. Why? And challenging those why is like, I want to do it. This is what I want to do. Like, well, then you're doing it wrong. If you're trying to recreate your entire application locally with a Lambda to an SQS to picking up from the Lambda, you are testing wrong. You're testing the inputs and outputs and make sure it matches the interfaces for those services. 1 + 1 + 1 = 3. 3 = 3 in local or even in the environment. And so minor debugging, but you're going to have those debugging either way. You're at that point, you're testing.
Even if you can stand up a local environment, it's not going to look enough like the real runtime area. Yeah, that's a solid point. What about, here's a question for you. Is Fargate serverless?
I think it's marketed as that.
Yeah, but like, I mean, this is like from our perspective, maybe a better term is cloud native. Because people try to argue that Kubernetes, like EKS, is cloud native.
It's AWS's version of Kubernetes, but I wouldn't call it cloud native in that sense. It's it's a wrapper around Kubernetes in a way, but I wouldn't call it cloud native. It's fine if that's where you're coming from as a cut your teeth into AWS. Fine, toss your containers in there and you know, work towards it, but I wouldn't consider it cloud native. No.
So you see something like an EKS as the first step in a lift and shift from an on-prem Kubernetes environment,
Mm-hmm.
but really you should be moving your stuff into, say, Fargate, like ECS Fargate over time.
Over time, yeah, Fargate's great. That's what we use. We use Fargate for our containers. It gives you a lot of control over what you spin up, what you don't use, auto scaling and things like that. It reduces a lot of the complexity, and I think that's the bigger part, is that you don't have to have that dedicated Kubernetes expert for that.
The thing I don't like about Kubernetes is, at least the way it's typically used, right? Like you have a cluster and then you have your pod. Like there's so many layers to it. And generally the proper way to do it is you have this giant cluster and then you segment it. And it's like, but now I just put a bunch of apps in like one piece of infrastructure. Like I don't want to do that. Like I get why you would do that in a data center, right? From an orchestration standpoint, it makes sense. But part of the beauty of cloud is like, I don't have noisy neighbor problems, right? Like I just know, here's my box and here's my stuff. And if I screw up my stuff, I've screwed up my stuff, not some other, the guys down on the other side of the building who are doing something goofy also on the same cluster. And
like, I have to restart the pods to see if it works again.
Christmas.
Restart the pods.
Or flip. Flip was the other one. Flip over to the other pod. Oh my God. You have no idea.
Oh, it's just
so many.
But the funny thing is that, it's an ingrained procedure though, because that's what you have to do for some of these pods that have a managed state, that have potentially memory leaks or memory issues, or the infrastructure isn't set up to release that memory. And so it was the funniest thing when we did switch to serverless. Is the question was, well, how do you flip? Well, how do you restart the pod?
How do you flip?
How do you turn it down? How do you turn it on?
We ain't doing that no more. No, those days are over. No, that was a great. We called that architecting for future growth, right? Like that was a great project, and it was so successful. Like you don't normally get, sort of technology rewrites, like technology driven initiatives like that to be so successful from a business standpoint. But to your point, like, and I know this because I was part of the group that was sort of advocating for some of the patterns we were doing, like with the enterprise, like multi-region, like some of the stuff that we were doing. And we had an 80% drop in P1s and P2s in that organization as a result of that transition. Like wild differences.
I felt like, who's that character from Always Sunny in Philadelphia? Like, what if we had it all event driven? What if we did this? And pitching that, and felt like it was the crazy guy pitching something. But, luckily, the boss I had at the time was very open to my crazy ideas and then took it and ran with it. And a year, I think it was a year or two later, it was finally kicked off fully, and full architecture for serverless and Lambdas and DynamoDB. And that was a great project. That was a lot of fun.
Yeah. Well, that was a cool thing too, because not only were you making a bunch of applications that we had inherited more stable, but you were actually detaching, or not detaching, what's the right word? Decoupling. Thank you. Decoupling it from downstream systems that were very unstable. Right. And so not only did you guys manage to make that our layer super reliable, and basically, unless we broke it, which happened because we would do stupid things, but those were just silly errors that we were able to fix quickly on deployment, usually. Like they were deployment mistakes. And then, but you remove those, we basically had no issues ever. And then not only that, but have that abstraction to where when other people were dead or messed up or whatever. And that was the cool thing. I remember looking at the logs with everybody, and like how many customers got to see their dashboard, their online banking dashboard, either in the mobile app or on the website, that wouldn't have if we didn't have that in there. Like it was thousands every day, because there was always some hiccup downstream.
Mm-hmm.
But this thing just provided that seamless interface. Really does speak to kind of the architecture in these complex environments of having those ODS layers that can abstract away underlying system stability or business problems.
Right.
So it's funny. I'm remembering, I'm trying to think if I should tell this story. The, the thing that I did with, that was one of my more spicy meetings I ever had at that bank was, because we were pushing for the multi-region aspect of it, and the cloud team did not want to do that, right? And so we were in this meeting, and we had all the CIOs are there for architecting for future growth. We had regular meetings on it, and I totally shamed them into it. Like it was one of those moments that I look back on. I'm like, oh my god, the fact I didn't get fired over that is pretty amazing.
That was one of the topics that we talked about last time too. Was the time and a place for pushing through something and the time not to. And I mean, and that one was a good use case for it.
Were you there that day? Do you know what I'm talking about? Do you remember this?
I mean, there was a lot of meetings like that.
You might not have been on the call. So I'm on the call. So I'll tell the story. It's of a ridiculous person. So I'm on the call, and it's the CIO that's over all of the infrastructure and operations space, right? So the cloud guys roll up to him, and then the CIO who's the head of architecture. And there's everybody's sort of hemming and hawing because the cloud guys have said it's going to be a ton of work to set up the extra region and blah blah blah. Everybody's hemming and hawing, and because I'm just a psycho or something, I don't know. I'm like, well, here's the deal, guys. This is how I see the problem. We're spending X numbers of millions of dollars on this thing, architecting for future growth, and that we're telling the business that we're doing this so that we can maintain stability and have all this stuff work great and have this high availability and all these different things. At the same time, we also know that US East 1 will fail. It happens about once every 18 months or so. So what I want to know is, if we're going to say no to the second region, who is it that's going to be the person that tells the business, yeah, we didn't want to do that with the day that thing goes down? Well, because it's going to go down. It's inevitable.
It also has blips here and there too. We put some monitoring around it that during the day, it might have a little blip that something will fail. And it's a very invisible fail because it's one out of however many thousands, but it does have interday blips as well. And our monitoring showed that we were flipping a couple times a day, or routing over to the
routing. Yeah. So, but the funny thing is that they all looked at me, and I'm like, my boss is going to get a call. This is not going to go well. And they're actually, you know what? You're right. Let's do it. And it was one of those kind of funny moments, because after the fact, I was just like, I can't believe I got away with that. But, and I, both of those guys I've been able to have good rapport with at times in the future. So it's been okay. But, I still look back on that as one of my more, salty with leadership moments, where I basically called them on the carpet and I was like, if you guys don't do this, I'm going to hang it around your neck when this thing goes down.
Yeah. And spending some of that reputation capital.
Yeah, it was not great. I like looking back on it was completely reckless. It worked out, and they were great.
It was great for
so reckless.
Like I said, with the SRE team put monitoring around that, and you don't know that there's little blips because, you might refresh the page and it's fine, but, that's not a good customer experience either. But it did flip a couple times a day.
With ultimately, and again, back to the conversation we were having last week without getting into it, right? Like, if you were to ask the question, well, why did they let me get away with that? I think this is all the things we talked about last week, but I think ultimately I cared about the right things, and I tied it to the business value for them, right? And I did it in sort of a confrontational way because I'm, psycho, but it clicked for them. Oh, you're right. we're spending all this money and all this time and all this attention to solve for this. But if we leave this big gaping hole over here, then we're not solving for it really. Right. And so, so the advice is like, well, first of all, don't be a psycho, and don't piss at people's Cheerios. Like, that's not helpful, but care about the right things and then tie it to why it matters. Don't, like one of our customers that one of the engagements we're on right now, we're working with this one guy, and he's super smart. Like, he really knows his stuff. But when he's advocating for his ideas, he's completely unable to make the case in a way that is compelling, because it's all focused around how stupid it is and how all this negativity or all this whatever. And I mean, everybody knows engineers like that. And so what ends up happening is, all you do is alienate people. You don't get anywhere. And so and this guy's kind of like just a case study in that. So that's why it's top of mind. But the real answer is having that expertise. And then again, going back to why does this matter? So if I'm talking to some security architect or something like that, and I'm trying to get them to change a policy, like you have to help them understand why it matters, not just tell them what they're doing stupid. And
I remember one of my teams, I was very pro serverless, pro Lambdas, pro Dynamo, and, I found, all these things. And I remember they came to me one time, they're like, okay, there's real spiel going in on, why they wanted to use a container, why they wanted to use Postgres. And I'm like, oh yeah, okay, makes sense, do it. And they're just saying, what just happened here? And they asked me, and I said, well, no, it made sense. Everything that you said made sense because you need to, as we've said earlier, you have to load a large file. You have to process this file. It's going to take longer than 15 minutes, and it's going to take you a significant amount of time to re-architect things to work with serverless just for the sake of being serverless. So at the end of the day, the justification makes sense to use the right tool for the job. And in that case, using a container and using Postgres for both of these tasks made the most sense because it was architecturally significantly harder to build this out just to be serverless, and actually likely would have cost more in the long run
to run it. Yeah. So like, I guess as we sort of wrap it up, right? Like, I think the thing to kind of the conclusion I would hope people walk away with is like, again, first of all, there are no solutions, only trade-offs. Serverless is great. It's like generally our advice generally is, or at least my advice generally is, be biased towards serverless. Don't use it if it's not the right choice, right? Like to your point, like go use, there's like a spectrum, right? Like Lambda's at one end of the kind of cloud native abstracted spectrum. If you're in cloud, EC2 is at the other end, right? Like a pure VM that you're going to go do stuff with. And then how you implement them also, there's some gradients in there. But, so the next step back from Lambda would be something like Fargate, right? Like use a serverless patterned container situation. And then the next step back from that would be ECS, or like without Fargate, just straight ECS. And the next step back from that would be Kubernetes and so on and so forth. And please, for crying out loud, don't use OpenShift in AWS. What are you doing? Like if you call me, I will email us. I will have that conversation with you. It's just there's just no reason. I'm sure our Red Hat friends will be thrilled with me for that. If you, that's the spectrum, right? So you want to stay as far towards the Lambda as possible, but you don't want to be foolish and dogmatic. And right. And that's where there's nuance and it's like, biases there's nothing wrong with biases. Biases can be good and useful as long as you know what they are and why you have them and you can ignore them when you need to.
It all comes down to planning, right? The first thing is that, if you were skipping right to either of these solutions, serverless or container, without doing your plan and having an idea of what are you trying to accomplish? What's the mission? What are my goals? What is my strategy? You're skipping some fundamental steps to make sure you're picking the right tool for the job. And bias in either direction is you're setting yourself up for failure. Now, you might be right sometimes, but I'd rather be right with data rather than right with a guess.
Yeah, fair enough. Cool. Awesome. Well, thanks for the time. Thanks for sticking with us if you did. And we'll be back to keep talking about this type of stuff and how you can kind of run your shop in the enterprise. So thanks, everybody. That's a wrap for this episode of Tech Council brought to you by DevGrid. Thanks for joining us as we dive into building smarter solutions for the enterprise. If you enjoy the show, please subscribe, leave us a rating, and share your thoughts on X, at DevGrid Inc., or at devgrid.io. Stay tuned for our next episode where we'll explore more ways to thrive in the enterprise. Until then, keep building.